Today was quite the bump in difficulty. I'm not gonna type the code in live, I'm just gonna show you my end result. So first I converted the terminal interaction into nested maps, where every key is a name and every value is a size for normal files, or an additional map for folders or directories. Right, and how did I do that? Here's the code. So I start with an empty result, fs stands for file system, and an empty path. So this means we're at the root. Later, if we change into the A directory, it will be A, and if we change into the subdirectory E, it will be AE. Right, then we split our lines as usual and immediately destructure into the first line and the rest of the lines. And if there are no more lines, so basically if it's nil, then we can return the result so far. Otherwise, we have to do stuff, namely call the refine function on our current line, and then it will find one of these alternatives. So this is the alternative syntax for regexes, either the ls case or the dir case or the size file case or the cd case, and depending on which case is actually found, the other groups will be nil. So let's simply check with the contour which one isn't nil. So if ls isn't nil, we don't really have to do anything. It doesn't change anything in our file system. So we simply recur. The fs stays basically as path stays path, and the lines are then destructured again into the first line and the rest of the lines. And for the other cases that follow now, either fs or path will change. So for the dir case, we want to insert a new empty hash map. And where do we want to insert it? Well, that depends on the path, right? So if the path so far is A, and we find an E directory, then we have to insert at A and then at E. And there's an associate function that allows us to pass in multiple keys for nested maps. That's quite handy. Okay, and for the file case, we don't want to insert a empty hash map. We want to pass the size, of course, from string to int, right? That's the only difference here between the two cases. And for the cd case, we have three subcases. For the root case, we change the path to an empty vector, just like in the beginning, no matter where we were before. For the dot case, we pop one from the path. So if it is actually AE, then we pop the E and go back to A. And otherwise, we go into a subdirectory, so the path gets longer. We conch the CD onto the path. Okay, then I have another function that computes for every path the total size. I start with a mutable Java map that will be populated by a recursive lambda. That's this recursive lambda here, so maybe let's look at that. So the lambda takes a path where we currently are, and a directory, basically, it starts out as a file system. So this is not just a name, not like in the example above, that's a map. Okay, and we want to take all the entries in the map and sum them together, but of course you can't sum map entries. That's why we map here, take the entry, which is basically also a key value of name, and then either a size for files or another map if it's a directory. If it's just a number, then we know we have the simple file case, then the size of that can be summed up. Otherwise, we do a recursive call where the name is conched onto the path, and then this is the subdirectories, then the new directory in the next recursive invocation. And note, we had to name our lambda here because the outer name collect will only become available here. Inside the lambda, it's not available yet, but fortunately, Clojure allows us to name our lambdas. Not every language supports this. I think neither C++ nor Java have that. Okay, and then after computing the size, we put it into our mutable Java hash map, and then we return it. And the return is only interesting for this recursive case here, so that then the size can be added up at our caller. Okay, and here the process is bootstrapped. Here we don't really care about the size, but we know as a side effect, now the map was populated, so we convert it into a Clojure hash map, right? So it's good style to start internally with a mutable collection, but if you hand the result out to your caller, then you should go to a immutable persistent value. Okay, right, then for part 1, what is our actual task? Find all the directories with a total size of at most 100,000. That would be, in our example, this guy and this guy, and we shall add them up, so that should be about 95,000, right? Yeah, here's the expected result. Okay, so we pass our file system, and then we call the second function to get this nice map from path to size, with a funny name here. And then we want to add them all up, but of course, again, you can't sum up map entries. So first we go to the values, that would be the nice numbers here. And then we're only interested in those that are at most 100,000, as described here in the description. Okay, and then we get the correct result. That's quite nice. And then for part 2, what do we have to do? Yeah, so the first lines are exactly the same. Then we check how much space is actually used from the root directory, so everything, the total space used everywhere. And we are only allowed to use 40 million max, and we happen to use more than that. And the difference between that, I call it dead, and we have to get rid of the dead to have enough space for our operating system update or whatever it was. Okay, and we do a similar thing here. We don't add starting at 0. We want to calculate the minimum starting at the biggest value there possibly is. And again, we can't really do that for complete map entries. We can only do that for the values, but we're only interested in those that can actually get rid of our debt.